Welcome to my PIPENET presentation. PIPENET is a powerful software tool for rapid flow analysis of pipe and duct networks. PIPENET has three modules. PIPENET Standard Module is a general-purpose module. PIPENET Transient Module is for modeling unsteady-state phenomena, and PIPENET Spray Sprinkler Module is specifically intended for design of fire protection system using water. What I would like to do now is to show you a transient module. So I have opened a loading system. So here is a petrochemical plant and there is a pipeline. Let's see now I can show the length of the pipeline. I can actually change also the number of decimal places. So you can see that this pipe, you can also see it here. That pipe is approximately 5.7 kilometers long. Yes, and then there is a shut-off valve which can close when the tanker, this is a sea tanker, it is unloading the port on the petrochemical plant, it is unloading onto the sea tanker. And this I will show you. This is ERC valve, emergency relief valve, remains open all the time. On the other hand, this valve closes and it starts to close at 1-2 seconds and ends up at 27 seconds. 0 means is fully closed and 1 means is fully open. So this valve is closing in 25 seconds. So once again, this valve closes and it starts to close at 1-2 seconds and ends up at 27 seconds. 0 means is fully closed and 1 means is fully open. So this valve is closing in 25 seconds. 25 seconds. So when this valve closes, the pressure here will increase, and we want to know how much the pressure will increase when this valve closes. That is aim. So the design pressure of the system is 15 bar. The design pressure of the system is 15 bar. So we will do a calculation. You can see how quickly the calculations were made. So I will do that again. Then we would like to have the look of the pressure in front of this valve. So this is the graph viewer, and we would like to look at the inlet pressure of the valve how it changes, and also the valve position. So the valve position as you can see changes in this way, because initially it is fully open and at 27 seconds is fully closed. 0 means is fully closed. When the line is too thick, we can slim it out. Also, we can put a title, and we can make the title bigger or smaller. You can also put a limit line, because I said you to remember that maximum allowed pressure, while the design pressure is 15 bar. So that is the maximum allowed pressure. Maximum. And I will show you how I can also put some labels and how to change the font size of that. I will write the valve pressure, yes, and I can move it, and as well I will add an arrow and I will move this arrow. As you can see, it is very easy. I do it slowly. However, if you have any questions, please write me a message, send me a message. So, okay. In this way, you can plug the graph, then you can copy and paste into your report. You can paste that into your report. Okay, this pressure, as we consider here, is too high, because this is our design pressure, and the pressure not only goes above the design pressure, it's going to stay above the design pressure. So, okay, so what is the solution? In this case, this is a real system from Asia, from Southwest Asia. In this real system, this was the first solution. The engineering company is from Korea, and they considered this solution. So this is called a surge relief valve, which is a very quick acting valve. Surge relief valve is a very quick acting valve. So I am going to put some attributes that represents the size of the valve. The maximum pressure is 14. So the maximum pressure is 15, so I will set the set pressure to 14, and the valve will be fully open at 14 bar, and it will fully close at 13 bar. Once again, the attributes represents the size of the valve, and I set pressure. I set the pressure to 14, and it will fully close at 13 bar. So this is going to open tank. So we will set the pressure. Don't forget the pressure here is constant now, and we set that to 0. So once again the pressure is constant, and we set that to 0. So I would like to have the results for this valve. So I can do that now, and I can show you once again. Yes, and I can do the calculation. So then we have to look at the graph and the inlet pressure. So on the current pressure we put the maximum limit of 15 bar as before. So you can see that the pressure is below the design pressure. So then we look at the position of the surge relief valve, and that is here. That is the position of the surge relief valve, and you can see it here. You can see it more clearly. So you can see that this valve, it will give me show to me the values, and it is only 14% open. Only 14% open. So this valve is too big, bigger than necessary. And the pressure surge valves are very expensive valves. So it can cost $500,000. So they are really very expensive valves. So we can make it a much smaller coefficient, much smaller, 50, which is much smaller than that, much smaller, and this is the CV of the valve when it is fully open. When it is fully open. You can see that the pressure is still below the design pressure. The pressure is still below the design pressure. So we look at the position of the relief valve and see this valve is opening about 53%, which is a good choice for a relief valve. The valve is opening about 53%. So what we will see if I can reduce the size of the valve. If I can reduce the size of the valve even more, maybe make it 15 or something like that. Let us see. So you have to do a calculation. So if we look at it now, the inlet pressure of the valve and we show the limit line. So now you can see that the pressure is above the limit line, even though I have a relief valve. In order to see the reason for this, I would look at the position of the relief valve. You can see that the relief valve is fully opened because it reaches a position of 1, because the valve was too small and it would fully open. And when a relief valve fully opens, it cannot control the pressure anymore. So, in this way, you can choose the optimal size of that valve. I will just show one more calculation because some of you are mechanical engineers and it will be interesting for you to see how PIPENET calculates the forces which arise in the pipes. So I'm going to say that this section is 1000 meters long. Yes, and that section there is 20 meters long and in this position this section is 100 meters long. Our aim is to calculate the force in the pipe section there. So you know, that to do is quite simple. So I have to click on that, and I will give the label F1, and that is on pipe 3. Pipe 3. I have to give the position of that elbow for the reference to be input and the position of that elbow for the reference to be input. So this is at an interior point, and that is 1020. This elbow is 1000 plus 20 meters from the input node of that pipe, and this elbow is also at an interior point in the pipe, and that is 1120 meters, because this is 20 meters long. 20 meters long. So I have to click OK, and I would say I would like to have the results for that force F1, and that's it. And then you see I can generate what's called the forces file, and I believe it's the same time step as the calculation. So then I have to click at OK, and we can now do the calculation. Okay. I can show the force as a graph. So you can see the force is not very high. It's about 1563 newtons. So because this is small pipe, now the other point is the sooner graph. Of course, if you want to do a pipe stress analysis, you cannot use input the time stress as the graph. You need a pipe stress program. So I asked PIPENET to create the tank FRC file. So let's open that and let's see. So here is a FRC file which I created, and one column here is the time and the second column is the force. You can see that when the valve closes, which took about 27 seconds, the force reaches its maximum value. So this is the file which Caesar, ROH2 and other pipe stress programs can read. So this is all I wanted to show from PIPENET Transient Module to you today. Thank you very much for attending my webinar. I hope all of you found my presentation enjoyable, useful, and it was as well interesting for you. If you have any question regarding Transient Module, please do not hesitate to contact me. Please join as well my presentation of PIPENET Spray Sprinkler Module. Spray Sprinkler Module is specifically intended for the design of fire protection systems using water. It complies with the NFPA 13, 15 and 16 rules. This module can be used for a wide range of design, including design of sprinkler systems, deluge systems, ring main systems and foam solution systems. Please contact me on my email olga@sunrise-sys.com or Skype Sunrise System Limited 3. I really look forward to hear from you. Thank you and goodbye.